So, hello everyone. Today I'll be participating in Leetcode's Biweekly Contest 122. Let's start in a second. Let's get into it. Dividing an array into subarray with minimum cost. Oh, this one loaded. I wanted to start with the easier one. Apparently, this ain't loading, so we'll start with this loaded. Then the cost of an array is the value of its first element. Okay, you need to divide nums into three disjoint possible sum, minimum possible sum. Wouldn't that be the sum of first three elements? It says at least three elements are there, so will not um, it will not proceed any kind of produce any kind of runtime error. 6 12 12 what? Oh, okay, so we'll have to consider the first element. No, we'll have to consider the first element. We'll push back nums of I, and here we'll sort the array ARR, and we'll include array of 0, array of 1, and nums of 0. That work. Perfect. Let's get it done. Find if array can be sorted if given a 0 array further documentation and an operation even swap any two adjacent elements if they have the same number of set bits. We'll have to do this operation a number of times. Adjacent elements if they have the same number of bits. Sort the array. Okay. Right. Let's have the size first. So my idea is pretty clear. I'll try to explain my idea at the end. I just want to store the number of set bits first. Area of I is equal to built-in pop count of nums of I. I want to create groups, and I will sort these groups, right? Yeah. If I is 0 or nums of I is equal to nums of not nums array of I double equals to array of I minus 1, then what we will do is run it till n. Then what we will do is push it in temp. Push what? Nums of Else, if that isn't working, what we will do is we'll sort it, or we can maintain our set instead, right? Yeah, we can insert into it directly. Then what I'll have to do is go over the set and push it in the answer, and at the same time I'll clear the temp as well, and I'll push the current element. If it's not the last one. So fine. Check if answer is equal to none. Looks correct to me. Let's see. It says heap overflow. Somewhere we're missing something. If it's not equal, then first we are pushing that into answer, right? Clearing the temp. Yeah, if it isn't equal to n, then it says heap buffer overflow. That means we're trying to access some element which we're not allowed to access. That's fine. We're pushing back into answer. We're clearing the temp. Okay. Right. True, true, false. Looks correct to me. Damn it. Why did I say false? It should be true, then why am I returning false? Let's see. Apparently a bad contest. Bad start to the contest. There's only 128. Oh, damn it. How can I be so dumb? Now I should pass. Okay. Minimum length of array using operations. Integer nums containing positive integer tasks to minimize the length of nums by performing the following operation in number of time, including 0. Minimize the length of num. Okay, select two distinct indices I and j from nums such that they are both greater than 0. Insert the result of at the end of nums and delete both of them. Okay, so there is no restriction on what I and j could be other than this. They have to be greater than 0 after performing the operation in number of 10. Okay. We'll ignore the call. They have to be greater than 0. Then we want to avoid getting to 0, right? Okay. Minimum length that we can achieve. And one thought I can say, I can apply binary search, because if I can achieve, let's say, x as the minimum length, then I can definitely achieve x plus 1, x plus 2 as the length of an array as well, considering they're less than the regional length of the array. Now, how do we determine that for this array if it's possible to reduce it to a number m which is less than n? So at the end, the number that will be left within the array is going to be 0, right? Otherwise, we can always remove two numbers and get any number into the array if they're not 0. So we'll try to avoid 0, right? Okay, so we'll try to avoid 0. So there's already one. I want I don't want it to be used with this one. Mm, could be one as well, right? What if we just keep taking mod unless, like, we have 0 or 1, right? But we would want to avoid having 1 as well. I think that's one way. And that would be greedy, and I do not have any strong proof to say that let's keep doing it unless we get a 1 or 0. If we get a 1 or 0, then we'll stop and continue from the next index. Let's say if I had 5, 5, 7, 7. Yeah, that's a good example. Let's say I have 5, 5 and 7, 7. 5, then 7 mod 5 would be 2. And 7 mod 5 would be 2 again. Then 2 mod 2 is going to be 0. So in that case, I'd be left with 1, 0. But if I do 5 mod 5 and 7 mod 7, so order does make a difference here. The order in which we decide to mod the elements, that will affect the result that we get. And we can't try brood because n is just large. Nice. Nums of I can be equal to 10 to the power 9 at max. That binary search thing does not make any sense because if we had a way with which we can determine if we can reduce this to x, that would have made this question a lot easier, and apparently we cannot determine that as well, so we'll have to think of something else. So the order in which we take the modulus makes a difference. And we would want to have as many different elements in the array as we can. That does not guarantee the best result, but it's better than having duplicate elements. Because if there already exists number 1, and if I start taking mod every other element with 1, then I'm just going to left with a lot of 1s. So if I can have an element which is already not in the array, then I can definitely reduce it to, then I can definitely be sure that I can vanish this number with a smaller number, right? Yes. So I would want elements that are not already there in the array. And if there is, then what if I have like 3 of them compared to 4 of them? If I have like 3 of them, then I can definitely reduce it to 1. Four of them. Okay, yeah. Three of them I can reduce it to one. Four of them will be two. So it's just division by two and then taking the floor. It's the natural division. Mhm. But the problem is, if I have a number and I have the option of having mod as x, y, and z, I decided to go with z. And proceeding further, I found an element with which I can only get z as the modulus. Okay, then I'm left with no choice. Then I'll have to get a z. So the question is about having as many different elements as I can have in the array. Oh, wait a second. So bigger number modded with a smaller number? Oh shit. A bigger number modded with a smaller number will always vanish itself. So the bigger number will eventually vanish and I will be left with a smaller number, right? Oh, right. Okay, so it's just the frequency. Well, the idea is pretty simple. I am still not sure if that would work. Looks like it would work because a bigger number modded with a smaller number, a smaller number modded with a bigger number, then the bigger number will eventually vanish and will be left with the smaller number. So we can always remove bigger numbers that way. Then we only want the smallest number that we have in the array and its frequency. Yeah, this frequency of the smallest number. We don't even care about this shit, or it's just let's make it more efficient, right? But is it necessary? I can vanish the bigger number with the smaller number, but what if the smaller number is being repeated like, yeah, that is true. What if the smaller number is being repeated like 10 times? And if I use that number to modulo with any other number, then I would get a better answer. Like 2 modulo with 10 is going to give me 2, but 10 modulo with 2 is going to give me 0. Similarly with 3. 3 modulo 10 is going to give me 3, but 10 modulo 3 is going to give me 1, which again is a separate number, a unique number, right? So taking a modulo with the smallest is not always going to work. Hmm, but we can do something. But what if we get to an optimal solution after a series of operation? Mm-mm. If I can have like at least one in the array, then I can definitely reduce the size of the array to 1, right? 1 is like the magic element in this case. But what if there are like multiple ones? I can't get rid of them, right? Oh, I can get rid of them. Oh, 1, I can get rid of 1. If I have like 1 and 10, then I'll do 1 mod 10. Yeah, right, I can't get rid of 1 either. If I have like 10 1, then I'll have to deal with them. Because 10 modded with 1 is going to give me 0, and I don't want 0. 1 is better than having 0. So if I can make, if I already have 1, then that's fine. If I don't, then I want to have 1. I am thinking of a much simpler case. If I don't have any 1 in the array, then the answer is going to be always 1. No, I'm so wrong. The smallest number here is 5. Mm, there will be cases in which getting 1 as the modulo is not possible. In that case, what will we do? If all the numbers in the array are not okay, GCD, can I like GCD of this number is not a 1? Well, GCD of these number is 1. I'll take the GCD, I'll just count the frequency of the GCD, right? I don't even know if that is going to work or not. I'll use the built-in formula. What if there were like 2 ones? Then I'd be left with 1. This will definitely work because my solution is based on the observation that I got from here. Let's see. No, it didn't work. Oh, okay. I'll have to do CNT plus 1 by 2 then. I'm still not sure if that would work. Oh my god. I literally had no idea, but yeah, kind of I guessed it with the modulus that GCD is what will give us the minimum element that we can form in this array, and we just want to find the frequency of this minimum element. Alright, cool. We already have 2 penalties, so we're probably not in a very good position right now. Divide an array into subarrays with minimum cost. Oh, is that an existing problem? Oh, first one. That's crazy. I took like 23, 24 minutes. Hmm. What a noob. I'm very slow today. There's a difference of like 2 points. My guess is it's going to be harder. 43. Divide an array into subarrays with minimum cost 2. Okay, it's the same problem. Evaluate its first element. Okay, disjoint contiguous subarrays. Is that difference between? Oh, now they have fixed the number of. That time it was 3, but here it's k. Is that the difference between the starting? Is additional constraint. Such that the difference between the starting index of the second subarray and the starting index of the kth subarray should be less than or equal to dist. In other words, if you divide nums into subarrays, nums till I minus 1, I1 minus 1, the second subarray, kth subarray should be less than equal to dist. Okay. Minimum possible sum of the cost of these subarrays. So we are given a kind of a window, right? We have to include the first element always, and then we have this window, and we'll move this window to determine the answer, right? What will we do? We'll try to have elements sorted in this window. This looks easy. I don't know why. It has to be equal to less than or equal to dist. So the first element we're always considering nums of 0. Now we want to consider k minus 1 elements, and this distance is greater than k minus 1, right? Yeah, it's greater than 2, k minus 2 as well, so it could be equal to, yeah, it's greater than k minus 2. It could be equal to k minus 2 as well. The first element we've already taken. If we consider the window of k minus 2 elements, we want k minus 1 elements. And if we consider a window of k minus 2 element, then it's not going to. What if it is equal to k minus 2? Let's say k is 3. Let's say k is 3. K minus 2 is 1. So the distance could be equal to 1. Okay, yeah. Because we're considering the difference, right? So we want a window of dist size. And we want to keep elements sorted within the window. But the problem is we would have to consider the sum, right? The sum of six elements. So this problem is only about maintaining a window of test size, and within the window we want to pick first k minus 1 elements, smallest k minus 1 elements, and we'll start this window from here. Suppose the window is like this. We'll consider smallest k minus 1 elements, then we'll move to window like this. Similarly, we'll move the window like this. The only problem is that to get smallest number within the window, we will have to think of some approaches or data structure. We can maintain a set, multi-set, keep pushing element, consider for the first window, but we're removing this one. Oh, we can remove it, but yeah. Oh yeah, finding the upper bound for that element, that would help us. Then we can add that. Okay, I have an approach. Let's see. I haven't like brainstormed a lot for the approach that I got. Like I'll try to implement it, and if I am able to think of any edge cases or problems, I'll try to handle them. If I'm taking pair, then I don't need multi-set. I can just use set. Let's call it set. Blame you don't want to consider. So move. Okay. I want k elements. Suppose distance is 2, then we'll run it till 2, right? 2 with index 3, then 3, yeah. First I want insert number, then the index. Now we'll try to take the sum of first sum, right? Yeah, we'll have a separate variable for min. Many. If x turns out to be 0, we'll simply take, otherwise we'll keep adding the first of I and decrement x, right? And we'll get our first answer by taking minimum of minimum, and that's our first answer. Now we'll try to slide the window forward. The indexing for window is going to be 1, r is going to be what, dest, right? Yeah, so that's our current window. Okay, while r is less than n, so now what we want to do is we want to remove l and we want to include r, right? We want to exclude l, and when we exclude l we will have to determine if it was a part of some or not, and for that I think we'll have to maintain a pair. mm, let's name it last, and it will be equal to I. Okay, now we want to exclude l, right? We'll get the pair, we will just check if it's excluded or not. So if nums of l is less than, if it's less than last of first, right, then it means it's included. Else if nums of l double equals to last of first, but l is less than equal to last of second, that means it's included as well. So we can kind of merge these two conditions, because the logic that we're going to write into both of them is going to be same. If that one is excluded, then we'll remove it. Nums of l. Mm, that's a problem. That's a problem, you see, with set. Instead of set, can we use the ordered set? So we can determine the next element that we want to insert. That's r plus 1 we want to insert, l we want to remove. So if l plus 1 is better than this one, because we have last now, and if you're removing any element which comes before last in the set, we want to consider the element which is after the last in the set. There's no way to consider that, right? uh, if we had some data structure, so we could have compared it with okay, I'm gonna go with that. There it is. Mhm. I just want to see if that works or not. Oh, set. Yeah, apparently it does. So yeah, mm, we have last right, so we can easily get the find by order of key. Then we don't even need to maintain last. Yeah, and we can always have it dynamically. Which one? 0. K minus first, right? Yeah. Then we'll be excluding. We have to exclude them in anyways. We just want to determine if the element that we are going to consider is consider is nums of r, comma r. If consider dot first, yeah, it's before that, right? You have to compare it with this element. If it's same, then no. I'll consider this one. Else I'll consider this one. Yeah, right. What if there's no element as k? For that case, that's like an edge case. For that case, we'll have an element which is greater than what we have in the array. So name it anything. Say 69. So we always have an element at kth position, right? Yes. So now what we will do is set dot erase. Which one? Nums of a comma L and z dot insert. This one consider I have incremented L. I'll increment R as well. Okay. Now if the element that you want to consider is not included, then simply I'll do set dot erase nums comma L. Okay, this thing is being repeated. Let's see if it works. Don't forget that we would have to take which was the first element of nums? Why it say time limit exceeded? Oh yeah, I don't want to continue the commit. Damn it. First let's try to see why it says 6. Let's check for first sample test case first. I think I can debug this. Six. Let's print it as a now. Nope. Okay, so it was 5, then it became 6. It was 5 because we want to consider two elements and we considered these two, right? Yeah, I want to consider two elements, then the difference should be at least. So we don't. So yeah, we considered these three elements, and the sum was 5, right? If we consider these, then am I missing something? Looks like I'm missing something. Okay, it is dist plus 1 actually. Now dist plus 1 is anyway going to be n minus 1 at max. 5, 6 and 6. Make 4 elements. This is 3, 4. This is 1. Yeah. Don't say do 3 inside of them. Okay. L and R will change as well. Yeah, dist will become dist plus 2. Right. Cool. Let's check for other test cases. I'm going to get a bad rank, I think. 36, 15, 5. Okay, looks well and good to me. Let's make everything long so we don't get a runtime penalty. Cool. Let's make sure we're not printing anything which can lead to MLE. Cool. Nah, man. What? It says 4. Apparently it should be 4. So like my logic is right, it's just that I'm not able to completely implement it the way I want it to be. So yeah, let's check. That's my third penalty. I'm gonna get a bad rank even if I'm able to solve this question. So it's 4, and it's from here to till here, right? And we want to consider two elements. We consider 3 and 1. We want to remove 6. We want to insert 1. 0, 1, 2, 3, 4, 5, 6. Yeah. We wanted to remove 6. We wanted to consider 1. Oh. Even if 6 is not a part of that. Oh, I am so wrong. Okay, I am so wrong. The implementation is shit. It could still be smaller than. Okay. So last element that I have considered is k minus 1. K in this case would have been 2. Then it would be 1, which is 3. Right? Yeah. And so we want to consider if consider dot first is less than that, or consider but r is less than that, then we would be removing last dot first. Okay, yeah, that makes sense. Cool. No, we have to consider both of them because it's going to be removed definitely. Mm. There's a bit of brainstorming here. So if the element that we're considering is okay, we'll divide it into two parts. We'll divide it into two parts first. I will try to divide it into two parts. If the answer was the part of the sum, we'll remove it and will include the after element. Yeah, this one. Right? Now we have removed it because it was the part of if. Yeah, that doesn't make sense, right? Yeah, cool. Now we can have the last element. Last again. Now we can check for the consider element. I mean, R is going to definitely be greater than that, even if they are equal. It can't remove that one. Then what we will do is we'll remove last. I mean, it will stay in the array, but it will not be the part of sum. We'll include consider now. We'll have to push consider. We're pushing it there. Yeah, that makes sense. This thing we can completely ignore. Yeah, do it now. Let's check for the original sample. 5, 15 and 36. That looks correct. Let's remove the print and redundant code. Where am I printing the answer? Yeah, yeah. Let's submit. How am I going to deal with this one? Oh, my answer is smaller than what they expected. Okay, let's try. We got time. Let's try to print things. Let's print it with the nums of 0 as well, so we get the complete answer. Let's look at the code. Try to figure out what we are doing wrong. There are k elements. 0th is the first, k minus 1 is the last element that we have considered. And the number that we're going to remove somehow is a part of that. Then we'll remove nums of L from the sum and find the next element, add it into our answer and remove. I think the after already contains the answer. You're definitely considering this number. The difference between these two numbers should be a number which exists. Nine two three two. 9232 is it a part of the array? It doesn't look like it. We're doing something extremely bad. Then we'll look at the next number. Consider it. Erase L from the set and then we'll try to see if consider can be a part of that. If it can become a part of that answer, at this point we have considered element. Because we have removed L, right? Okay, what if L was already part of that? Oh, we're removing L here. Okay. I'm not even considering this, man. What's happening? Expected is this. What we are getting is this. Come on, let's work. I don't have much time. There's not much acceptance of this question as well. Oh, looks like we're getting the right answer. 5-4. Yeah, cool. Cool. Let's remove print statements. Submit it. Damn. Apparently, yeah, the issue is we are erasing nums inside of this if condition. But what if this if condition never executed? Then we're not even removing L, which is the part of our sliding window, which is what we have to do with the L, right? So the idea was that you just have to consider that if this if never executed, then this flag will always stay false. Sorry, true. In that case, you're explicitly removing it here. Otherwise, the question is pretty simple. I mean, I have explained the approach earlier, and I think this question was all about having that idea in your mind. The implementation is tricky, no doubt about that, but the thing that I explained earlier, like you have to consider window of distance plus one size apparently, and you have to consider first k minus one elements, which means the smallest k minus one elements. Keep sliding the window size is fixed, and keep getting the um, those the smallest k elements. This whole logic is all about finding those smallest, the sum of those smallest k elements, and it definitely did help us here finding the kth element and finding the k minus 1th and kth element. Yeah, apparently a good contest. I'm expecting my rank to be around under 500 because um, this is apparently not true, and we have like 4 penalties as well. So considering both of these factors, this is frozen. I don't know why it freezes in the middle of the contest, but apparently there is a problem and it hasn't been fixed yet. So it will get resolved soon. I don't think it will be resolved. It's been there for like months now. And looking at the accepted solutions for the fourth problem right now, It says 274, but in reality it would be somewhere around 350 to 400. And considering I have like 4 penalties, I'd say my rank would be around 500. Could be worse than that if this number increases rapidly in the last 5 minutes. So yeah, that is all about this contest. Just to have a little walkthrough of what I have done in each of this question. I think in this particular contest, question third was incredibly good, honestly. Hmm. The website is very slow. I want to go in order, that's why I just want to try and get this one load first. Hmm. Oh, none of them loaded. What about people who are actually solving those? That's really unfair. Hmm. Okay, yeah, nice. So the question was that you have to divide a given array into three disjoint plus contiguous subarrays. So suppose this is the array, you have to place like two big walls in between elements, two big walls, such that you are able to divide the array into three subarrays which are disjoint, right? Which means disjoint just means that there is no index which is common to the subarrays that we are considering. So yeah, just place two big walls and consider them as separate arrays, and then you have to just consider the first element of the uh, separate arrays. In the end, you'll have three separate arrays, and you just have to consider the first element. So the idea is that nums of 0 is always going to be in the answer, because it will always be a part of one of the subarray and it's the first element. That's why it will always be the part of the answer. And now we can do whatever we want with these elements. We can place walls anywhere, right? Those two walls that I'm talking about. What about placing it just in front of the smallest two elements, right? The greedy works, right? So that's how we are doing it greedily. We'll sort it from here, right? We'll sort it from here, and then we'll consider the smallest two elements, which are array of 0 and array of 1, right? That was the first problem. Moving to the second problem. Hopefully it loads. This problem, I mean, yeah, it was kind of interesting, but more of an easier side. Mm, no. Okay, yeah. So the problem was that you are allowed to perform some operations, which is you can swap two adjacent elements if they have same number of set bits. Set bits are like if you write a number in the binary representation, the number of ones is the count of set bits. So what I am trying to do is I'm trying to form groups of elements, adjacent elements that have same number of set bits. Suppose these three elements have same number of set bits, and I'm forming a group with these three elements. Then the other group would be of these two elements, if they have equal number of set bits. And what is the benefit of that, of making that group, is it allows you um, to arrange them in any order that you want. So basically you can sort them. That's what the question asks us, right? Return true if you can sort the array. So you know that you can arrange these elements in any order. Why not just sort them? Yeah, so that's what exactly we're doing. Temp is to store the element, and we just don't so that we don't have to explicitly sort each group, we're using multiset. Otherwise we could have done that with vector as well, but I guess multiset looked more like a better solution, better data structure. So yeah, I'm just checking if it's the first element or the array. Yeah, first of all, I am forming another array in which I'm storing the number of set bits for each element, and if the number of set bits is equal to the previous element's number of set bit, then I'm putting it in into temp, which means one group. And if the group ends, this part will be executed. In that case, I'm putting the elements in sorted order in another array, which is answer. At the end, I just have to check if I sort this array, if answer is in sorted form or not. That's just what I want to check. For that, I'm sorting nums and checking if it's equal to the answer array that I have formed. That way we can always make sure if we can sort the array or not. I'm going to third and fourth. Yeah, so the question was, I have to minimize the length of the array as minimum as possible, and the operation that is allowed to us is, if we can pick two indices, let's say I and j, such that their value is greater than 0, then we can remove both of them and insert the modulo of nums I and nums j into the array, into the nums, right? So we just have to tell what is the minimum length of nums that we can get after performing this any number of time, right? So the approach to solve this question is that if you have two numbers, let's say 1 and 10, you can always reduce this to the smallest number, to 1. Why? Because 1 modulo 10 is 1, right? So for any number, let's say x and y, you can always reduce it to the minimum of x and y, right? But how will you determine the minimum number that you can have inside the array? How will you do that? Like, initially you can have some elements, but there's no guarantee that it's going to be the minimum element. So to determine that, what we can do is we can take the GCD of all elements, and that way we can determine what is the minimum value that we can get inside the array. And I'll just use the count of the minimum element that we can form. In this case, GCD is the minimum element which I can form in the inside this array using this operation. And then I'm just counting how many time it occurs inside the array, and I'm just dividing it by 2 and taking the ceiling of it. Why am I doing it? Because let's say if I have like 3 consecutive 5 as my last array, then I can like use 2 5, convert them into 0, then I'll have inside the array I'll have 0 comma 5, and according to this situation, this condition, I will not be able to perform any operation further, so we'll be left with two of them, right? So if the number of count is odd, then we'll have to add 1 to our answer after dividing by 2. That's exactly what I'm doing. And why 1? Because in case the minimum element does not exist, like the GCD that we have found is not inside the array, like in this question, in this example, the GCD of these elements was 1, but it's not inside the array, but we want at least 1. We are using these elements to form at least 1 right? Yeah, so we will at least have, like, in this question it's not possible to reduce the length of the nums to absolute 0. That's why. Now going back to the last problem, which is tagged as the hardest problem in this set. The idea is pretty simple. I'll tell you what exactly am I doing here. So basically you're given an array, and there are two integers that have been explicitly given to you, which is k and dist. K, so it's like the harder version of the first problem that we have already went through. So in this question you have to divide the array. Like in the first question it was 3, but here you have to divide it into k disjoint contiguous subarrays, right? And there's an additional condition as well. The additional condition is that uh, the starting of the second subarray and starting index of the second subarray and starting index of the last subarray, which is the kth subarray, should be less than equal to dist, right? And this is like the what do I say, like the biggest hint to this question, to solve this question, which is what we can do is we can have a window of that size. Like I know that I cannot expand this window if I have to pick like k minus 1 element, because 1 will always be a part of the answer, the first element, just like we considered it in the first question itself. So now considering for k minus 1 elements, I will try to maintain a window of dist size, because the difference cannot be more than that. And if I want to pick k minus 1 elements, I'll have to pick k minus 1 element from the window itself. And yeah, so the obvious answer is I'll have to pick the smallest k minus 1 elements from the window, right? And then what we will do is we'll move the window just like this. Suppose we considered these 3 elements, then in the next phase we'll move the window by 1, like towards right. The size of the window is fixed, and then we'll consider this, and out of these 3 windows that we found, we'll try to find the sum of smallest k minus 1 elements, and out of the 3, whichever has the minimum sum, we'll consider that one. So I'll get a little into the code that I have written. So to find the smallest k minus 1 element from a window in like the optimal way, what I have done is, first I have created the window in which I am maintaining an ordered set. So basically it's just a set. It just provides us with an additional functionality, is that we can determine the order of uh, we can determine which element is like the kth smallest element inside the set. We can find that with this method that this data structure provides, which is find by order. So if I'm doing find by order k minus 1, which means it's giving me the k minus 1 index of the element, like k minus 1th index, the element which exists on the k minus 1th index in the set, 0 based indexing. So yeah, here I'm pushing dist number of elements. So actually uh, logically if you see, you will understand that to have a difference of dist, we can have at max dist plus 1 element in the array. That's why I'm considering a window of size dist plus 1, and I'm pushing it into the set. And then for the first window I'm just considering the first k elements, k minus 1 elements. I have decremented k by 1, and that's like the smallest, because it's set, it stores element in sorted order already, so I can consider first k elements. And now sliding the window towards right is a bit tricky, right? For that, what I am doing is, first I'm saying like Like this is the window. Now I have to remove 3 first, right? To move the window towards right, I have to remove 3 and I have to consider this 2. This 2. So the new window will become something like this. I've divided the code into two parts, in which first I'm removing this one and adding this one in the second if condition. So in this if condition, I'm removing um, the lth index element under certain conditions. If it's like if you go through this code by your own, having the idea that this condition is about removing lth element and this condition is about including the rth element inside the window, then you'll explain it on your own pretty easily. So just the idea is, if let's say I have this window, and if I want to remove this element, then I want to make sure that out of this window I have considered some elements, k elements, to be the part of my answer, right? And if I want to remove this element, I want to first consider if it was the part of the answer or not, right? We have to consider that. If it is the part of the answer, then we are executing this. In that, first we are removing nums of L from the answer, because if it was the part of the answer, it will no longer be the part of the answer because we're moving the window towards right. And if we're removing one element, we'll have to add another element, right? So which element will we add? The kth element, right? So I am removing the lth element and adding the kth element from the set, right? See, in the answer I subtracted nums of L and I'm adding the kth element, and I'm removing the lth element from the side as well. Now I have to add this to the window, right? Now initially the window was like this. Now I have removed L, so the current window is something like this. Now I have to include this 2 inside the window. So before including the 2, I am just considering that the kth element, kth smallest element, which is like the last smallest element that we have considered in our answer, is actually smaller than this or not, because this could be a part of those k elements, right? So that's why we have written an explicit if condition in which we are considering that if the rth element, this consider is nothing but the rth element, is smaller than the last considered value of one of the k value, right? If it is, then we'll remove that element and we'll include consider in our answer, and we'll push it. Yeah, we'll push it into the side as well. So that's how we can always make sure that we're picking the smallest k elements from the considered window, from the considered set of elements. Yeah, in the end we just returning the answer. So that was all about this video. At the end, this question had around 600, 300. Yeah, 300. Yeah, so I can say somewhere around 500 would be my rank. So yeah, that's it for today. I hope you liked the explanation. Okay, bye.